Hello, everybody. Hello, everybody. Hope everyone is doing fine. My name is Ronald Kashweka. Um, I usually upload videos where we solve questions or we discuss a topic, mostly in management accounting, financial accounting, cost accounting, and management accounting. So I actually conduct online lessons. For more details, you can simply contact the line, the phone number that I'll put in my details of this video. And after watching this video, don't forget to subscribe to the channel for more and also for the support. I appreciate, and also to like the video, share, and also to comment. Okay, so let's get to today's video. So when I was passing through this paper, management accounting, they wrote it on the 15th of March 2022. I actually noticed a question, bumped into a question number two, that I would actually like us to solve. So that question will basically take us back slightly to our secondary days, because it basically more like involves a lot of math. Okay, but math is actually a good thing for an accountant. So you're an accountant, you got this, trust me, it's not a hassle. So the question is this is the question. So what I'm going to do is I'll read through the question, and then we'll only solve A and B. We just solve Roman numeral 1. Okay, because of time, we just do A and Roman numeral 1. So if you would actually like a session that is more detailed and where we solve more questions or more papers, you can hit me up on the number that I'll drop, so that you join my classes. Okay, like I mentioned, my name is Ronald Kashweka. Welcome. Right. So our question today says, a publishing firm sells a popular novel at a cost plus 100% profit markup on marginal cost of each copy. Okay. In 2020, a total of 100 copies were sold. The following production cost per copy has been made available to you. We have direct materials of 45 kwacha, direct labor of 40 kwacha, variable overheads of 15 kwacha. The total is 100 kwacha in marginal costs. Okay. Fixed production overhead is 80,000 kwacha per year, while annual fixed selling and administration overheads amount to 70,000 kwacha. Required: calculate the current selling price. Okay, calculate the current selling price. That's the first requirement. And number two, they've given us this information and they want the optimal price. Okay, calculate the current selling price. Uh, so we'll start with the first one. We'll start with the first one. So what they are telling us is a publishing firm sells a popular novel at a cost plus 100% profit markup uh, on marginal cost of each copy. So for us to actually find their selling price, we'll have to use this particular approach that they use, which is the cost plus 100% markup only on marginal cost. What do we mean by marginal cost? Marginal costs are variable cost or direct cost or simply production cost that directly link to us producing our inventory or producing whatever we sell. Okay, so this does not include fixed cost. So what we do for us to find this selling price, we'll simply get all our variable costs. As per our question, our variable costs are direct material, direct labor, and variable overheads. So we have direct material, which is I think like 45, which is like 45 kwacha per unit. These are per unit costs, by the way. 45 kwacha per unit. Let me just change this to currency. Direct material, and then we also have direct labor, direct labor, which is 40, and then we have variable overheads, variable overheads. Okay, these are all variable costs, by the way, or simply marginal costs. So 15 kwacha, so put our 15 kwacha right here. What I'll do is I'll sum them up. to get our total marginal cost. Our total marginal cost is also known as production cost or variable costs. These are costs that are directly linked to our units or production. Okay. Okay. So let's look at the approach again. They're saying a cost plus 100% profit markup on marginal cost. So we have the total cost, which is 100, and then we bring in the 100% markup. The 100% markup will definitely be the 100 again. So our selling price, if we want to make 100% of profit, will be 200 rather. And our selling price is 200. So what did we do? We just got the total marginal cost or total variable cost or total production cost, and then afterwards we added a markup of 100%. So now we have their current selling price of 200 kwacha. Okay, so this was more like just a tiny bit of what I wanted us to talk about. What I want us to talk about, the main thing, is B. Okay, let's do this. Let's begin. Management is concerned about the low sales demand resulting in a loss. To this effect, management feels changing pricing policy from a cost plus to an optimal pricing strategy and would automatically change sales demand and result in profit. Okay. Management wants to change its approach or basically its strategy from a cost plus pricing approach to an optimal pricing approach. What's an optimal pricing approach, or what's an optimal price? An optimal price is the price that maximizes the business's profitability whilst making sure that the business remains very attractive and to customers. It basically balances demand, competition, and also the cost of running that particular business. That's what an optimal price means. An optimal price is basically the perfect price for your product or the perfect price for your inventory. Imagine a price that will reduce the costs, okay? A price that will maximize the profit, a price that will ensure you remain competitive, okay, and a price that will in turn increase demand for our business. Okay, all right. So that's what an optimal price is. So to this effect, management feels changing pricing policy from a cost plus to an optimal pricing strategy would automatically change sales demand and result in profit. Market research shows that reduction in the selling price per copy from the one calculated in A, which is the 200 kwacha we got, above to 120 kwacha will increase sales demand to 5,000 copies. There will be no change in the variable cost per copy, but fixed production overhead will treble, while fixed selling and administration overhead will increase by 50%. Okay, I know this won't really affect what we'll be solving since we're actually just calculating the optimal price, but let me just make mention when they say for instance, there'll be no change in the variable cost. The variable cost will still remain the same. The variable cost per unit will still remain the same. But the fixed production overhead will treble, meaning the fixed production overhead will triple, like it will be 3 times the current amount. So you have to multiply the fixed cost by 3. And then the fixed selling and administration overhead will increase by 50%. Basically, you have to get 50% of the fixed selling and administration expense and then add it to the fixed selling and administration expense, which that basically that's what this statement means. Okay, so now they're saying calculate the optimal price. Okay, so this is the main thing that I wanted us to talk about: calculating the optimal price, calculating our best price, calculating our perfect price, which will increase, which will reduce our competition, or basically which will ensure we compete effectively, and which will increase our demand and also balance our costs. Okay, let's get to it. So what are we supposed to do now? So when we are calculating the optimal price as per this question, we'll have to use what we actually refer to as the linear demand function. That's what I want us to talk about. The linear demand function. Okay, so this is basically a formula in business economics that we use to actually show you the relationship between the price of a product, the quantity demanded, and how it affects it or how it relates to it, and also how it relates to the price when the demand is at zero, and also a difference or basically a slope which represents the change in price per unit and also the change in quantity. So the linear demand function is P is equals to A minus B Q. The linear demand function is equals to P is equals to A minus B Q, where just explain these letters so that we get to understand them, where our P, guess what it represents? I'm listening. Okay, it's true. I'm not really listening, but you are correct. It represents the price. So P represents the price of the product that we are selling per unit, or the price of each product. That's what P represents. And then we have Q, which represents the quantity. Not just the quantity, but the quantity demanded. The quantity demanded. Okay. Yeah. And then A represents the price when demand is zero. A represents the price when demand is zero. And then B is a slope which represents the change in price per unit compared to the change in quantity. Okay. All right. So basically, this is the linear demand equation. Okay. So from our question, what we are getting is, so basically what we are getting is from the current information, their demand is actually at 1,000. Okay, their demand is actually at 1,000, and their price is 200. So it means when I'll just do Q and price. So when Q, the quantity is actually at 1,000. Okay, when the quantity is actually at 1,000, the price is 200 kwacha. Okay, but when the price is 120 kwacha, the quantity is 5,000. Okay, so when the quantity is 1,000, the price is 200 kwacha. When the quantity is 5,000, the price is 120 kwacha. Okay, so let's just create equations from this. Okay, so basically let's just create equations from this. What is this telling us? Okay, so basically what this is telling us is when our price, let's use this formula, when our price is 120, okay, when our price is 120, we don't have A, we don't have B, but our quantity is 5,000. Okay, but when our price is 200, we don't have A yet, but our quantity is 1,000. Okay, so I know you probably have a formula or a method that you use or some technique that you've mastered. But me, I like doing things the way I understand them. Okay, these are two separate equations. Okay, these are two separate equations. If we want to actually just finish up this equation, or basically we just want to we just want to basically this equation is something like this. It's 120 is equals to a minus 5000b, and then at the bottom we have 200, which is equals to a minus 1000b. Okay, how about we just make this a simultaneous equation so that we find the value of a and also we find the value of b. How do we do it? Okay, remember when I said we bring in a bit of some aspect of math? This is it. Okay, so what I like doing is I'll just do the substitution. Okay, I'll just do the substitution method whereby I'll find let's do this. I'll just do substitution. So basically I'll get the first one. You can get either. I'll get the first one and I'll make a the subject. So basically when making a the subject, I know my equation will look something like this. A is equals to we'll have the negative 5000 still there. B minus 120. It will be something like this. And a will actually be a negative as well. Yeah, something like this. Let's see, find a better way of actually putting it. Okay, or rather, let me do this. A minus 5000b is equals to 120. Okay, A is equals to 120 plus 5000b. Yeah, something like this. Yeah, this is much better. So basically have the equation that defines A. This is A. So I'll get the second one. The one with the 200, and I'll find the value of b. So it will be like this. 200 is equals to a, which is 120 plus 5000b, we close, minus 1000b. Okay, all right. So we know it's something like this. 200 is equals to 120 plus 5000 b minus 1000 b. These are like terms. So it will be 200 is equals to 120 plus 4000 b. When we subtract the two like terms, it will be something like this. So let me do 120 plus 4000 b is equals to 200. Okay, I'll take the 120 the other side. So it will be 4000 b is equals to 200 minus 120, which is this. Then what I'm going to do next is I'll subtract the other side. It will be 4000 b is equals to what's 120 minus that's about 80. So it is equals to 80, something like this. Then it will be b is equals to 80 divided by the 4000. Okay, so our b will be 80 divided by 4000, which is 0.02. So our a, which actually represents the price when demand is 0, is actually 0.02 kwacha. So 0.0, okay, it's actually our b. We haven't found the a yet. Let me just make mention it's actually our b. So our b, which represents the slope between the change in price per unit and the change in quantity, is actually 0.02 kwacha. So now let's quickly find our a. So now we have our b. So how do we find our a when we have our b? This is how we find our a. So our a is equals to 120. You can use either equation plus 5000b. Okay, 120 plus 5000b. So our A will be is equals to 120 plus 5000. In brackets, we have our 0.02, which represents our B. And then it will be A is equals to 120 plus 5,000 times 0.02. Just calculate it. 5,000 times 0.02 is 100. So this will be 120 plus 100. So our A will be represented by 120 plus 100, which is 220 kwacha. Okay, so now we have our A and we have our B. That was the first step. Like I said, the first step, we have to find the values of our A and we find the values of our B. So now we have to satisfy the linear demand function or the price equation. So to be price is equals to, we know it's A minus B. So our A is 220 minus 0.02 multiplied by the quantity. So I just put Q. Okay, so it will be 220 minus 0.02 Q. Okay, and then now what we're supposed to do next, we basically have to compare, because we know our marginal revenue. By the way, here we want the optimal price. The optimal price is actually like marginal revenue. So our marginal revenue is the same as our marginal cost. So basically do a comparison. Okay, we'll basically do a comparison, but firstly we'll have to find our marginal revenue. So how do you find our marginal revenue? Marginal revenue is equals to our price multiplied by our marginal price multiplied by our total quantity. Okay, our marginal price multiplied by our total quantity. So it will be something like this. Marginal revenue is equals to our price. We have our price there. Our price is 220 minus 0.02 Q multiplied by the quantity, which is Q. Okay, so our marginal revenue will be 220 Q minus 0.02 Q squared actually. Just a second, see how I can show the power. Okay, I'll just put 2 here, but we know it's actually squared. Okay, this is 0.02 Q squared. The last 2 is a power. I repeat again, the last 2 is a power. Okay, so now the way it's going to be like is like this. It will be something like this. Marginal revenue is equals to 220 minus 0.04. That's multiplied by the power, and then we have a Q to be something like this. And then we know our marginal revenue and our marginal cost is the same. So our marginal revenue meaning will be 100 kwacha, because our marginal revenue is 100 kwacha. So it will be our 220 plus our 0.04 Q is equals to 100 kwacha. Then what do we do next? It will be 0.04 Q is equals to 100. Okay, yeah, is equals to 100. That this is actually a negative. Just a second. And here it's actually a negative. Okay, yeah, so it will be is equals to 100. This is also a negative, by the way. It won't really allow me, but it's a negative. Let's see, I'll find a better way of putting it. Okay, I'll actually take it the other side. So let's make it something like this. 220 minus 100 is equals to 0.04 Q, which will actually become a positive because I've taken it to the other side. So, and then it will be, again, I can switch it to 0.4 Q is equals to 220 minus 100. 0.04 Q is equals to, when you subtract the two, our answer will be 120, I'm assuming. Okay, and then Q will be 120 divided by 0.04, which will give us 3000. So basically the optimal quantity is 3000. So that's what we have found. The optimal quantity is 3000. Now that we have the optimal quantity, just say optimal quantity. Okay, so the optimal quantity is 3000. So now what we are looking for is the optimal price. So how do we find the optimal price? We find the optimal price by getting the price equation, which is P is equals to 220 minus 0.02 quantity. So we'll basically do this. P is equals to 220, not the 200 that I wrote on top, I'll change it, minus 0.02 multiplied by the optimal quantity of 3000, and then it will give us the optimal price. Okay, all right, so like this, it will be something like this. P will be 220 minus 0.02 in brackets 3000. Okay. Okay, so it's giving us 160. So 160 will be the optimal price. So 160 is actually our answer for this question. Calculate the current selling price. Now the selling price we've calculated is 200, but this question calculated the optimal price. The optimal price is 160 and the optimal demand is 3000. Okay, so we have firstly find the values of A and B and then found the price equation, which is the linear demand equation or the linear demand function, and then we have equated the marginal revenue to the marginal cost because they are always supposed to be the same, and we have found the optimal production in volume, and then we have found the optimal selling price. Okay, so this is it. Please don't forget to subscribe to this YouTube channel and kindly comment the next question or topic you'd like us to actually solve, or you would actually like me to share a video on. And don't forget to subscribe, share, like the video, and also for more detailed videos and also live online sessions, you can just contact the number at the bottom, or you can WhatsApp me on the other number that I'll share at the bottom as well. All right, thank you very much. My name is Rand Kashweka, and I'll be closing right here. Have a blessed day. Have a blessed night. Thank you.